For today's webinar, we're excited to bring you an industrial sheet metal part. And today's webinar will also have a little bit of a special format, as today I picked this industrial sheet metal part and we'll do the rollback and we'll look at how that was approached. But I'm also going to take special time today to go over the release of Geomagic Design X 2025. So we had a release in this last week or so, and I figured I would take time out to highlight some of the enhancements and the new features, tweaks, bug fixes, all that sort of stuff on today's webinar, and just highlight some of those things as part of the show. So with that, we'll go ahead and jump over to the exact industrial sheet metal part that we're working with. So as you see here, we have an industrial sheet metal part, a widget of sorts, could be a part on anything, whether a appliance or whatever. I actually do not know where this comes from. But the general idea of sheet metal modeling is definitely a great useful skill to understand how to approach that sort of project within Design X. And this one, the person that modeled it was not me, and they took a very interesting workflow or approach to it. So that is one of the reasons why I chose this specific model here. Nothing groundbreaking or crazy as far as the geometry, although the approach that was taken to modeling it was novel and it was pretty neat. So I figured I would highlight it on today's webinar. So in general, I will say that when we have sheet metal parts that we model inside of Design X, we do model them as a solid. And again, this is like a stamped out sheet metal part too. So this has got a few different stages here. It looks like it was stamped and then bent afterwards. But what we tend to do is model that as a solid part and then do the other features as far as flattening and stuff inside of the CAD software, just so people understand before we get into it. That is the approach that we generally take. So with that, this was scanned with a portable CMM arm type device. So that's what it was captured with. Yes, you could, in this instance, you could use a lot of these different devices to capture it. There's nothing specific that really makes this part better for any certain scanner. It really just depends on the scanner you have that's available. It's better than the scanner you don't have, right? So if you have any of these above, they should be able to scan this part and handle it just fine. And they all have their various techniques, and they're a lot of fun to use. Maybe the drone. So, okay, maybe the drone would probably not be what I would scan this part with. So there is one on the screen that you might not want to. Although, let's see if somebody thinks that is a good idea. I want to see you scan a part with the drone and send me the video. I'll highlight it in the webinar. But with that, we'll go ahead and get started, because I'm sure I'm going to go long today, just to warn you, because once I get going on these new features, I think I get a little excited, get a little long-winded, but I'm sure it'll be valuable information for everybody. So let's go ahead and jump over. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes and it's redundant for you, but I just wanted to make sure that anybody that's watching this for the first time understands what Design X is really quick before we dive into the application. But Design X is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners, even all kinds of different devices were creating this type of data, and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter Design X. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right hand side, whether these are the high level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this Design X product is all about: grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the Design X portion. All right, so here is the model. Just rotate it around as usual. We go ahead and rotate the part around, take a look at it from all different angles, the final deliverable and what it looks like. So you can just kind of see what the goal is, what we're going to go over. And this specific part, as you can see, it's just your run-of-the-mill sheet metal stamped part. It looks like it was stamped, then bent from there. And, it's nothing special, but we had a collection of internal files that we use for testing and modeling examples. And we, a lot of times with those, try to take a second and model them in a variety of different ways and think outside the box and just approach them different ways for testing and stuff. And that's what this one is. Basically, I came across it, and it had a few different original things to it of how the modeling was done. So that's why I wanted to highlight it. So when you see it and we roll through here, you're going to see, well, probably wouldn't do it that way. But yeah, we were purposely trying to model it slightly different to find a different method and just go about it different ways, because different people think about modeling in a whole host of different ways. Right out of the gate, you'll notice we did an extrude to account for this piece right here. You can definitely see, like, wait a minute, what's going on here? So we're going to go ahead and model it from that direction and extrude that piece there. And then from there, we're going to add the fillets that wrap around that side. So if I hide the solid, you see what we're doing there. We're trying to wrap around the outside. Then we jump forward. And one of the first things you'll notice here is we did a cut on an angle. We did a cut using this guy right here, this plane. So you can use reference planes as cutting objects, especially if you're cutting all the way through. And that's a pretty efficient modeling method to model things that way. So that is a really interesting little detail there of just fitting a plane to that angle and then cutting the solid there. Now coming back and adding a fillet to that. You'll also notice that we have these little markers here. These little markers are just, we created dummy points and then renamed those dummy points with notes, right? So that's what this is right here. Some people use these, if it's a training file or whatever, they'll use this concept which we've discussed in the past of just using these dummy points as a lightweight way of applying notes or a position within the history tree to mark something from there. Now we're going to go in and extrude a couple surfaces from the top to cut that solid that we've created so far. And you see here in this instance, we did a double cut, what I call a double cut. A lot of CAD packages allow you to do this. where you can cut with multiple surfaces. Unfortunately, SolidWorks does not let you do that. You can only cut with one surface at a time, but this was a double cut there. So keep that in mind if you do these, depending on where you might want to send the data to. So now I'll turn the surfaces off. You see here they extruded a block there, that big old block, just to cut that one little piece away. Again, we are thinking outside the box with this modeling approach, just going about it in a variety of different ways. And you see there, if I just turn this off, it's just accounting for that. And we will roll forward. We will keep on keeping on. Now we are extruding this piece down to account for that bottom. Then you'll see that we fit, just turn the solid off real quick. We fit 3 planes here all the way around. Use those 3 planes to do a cut. So you see here, you thought doing a double cut was really cool. We just did a triple cut. We used all 3 of those planes, and we cut that solid with all 3 of those, and then left the remaining body there. There we go. So again, we just used reference planes to cut that. Now we will jump over, and we used another reference plane on that side. We actually could have just done a quadruple cut, add this one to that, just go back in and change it. Now we can go back and we just fit a surface extrude here, like so, and then cut it away. And now jump forward. We'll just do a fillet there and jump forward. Now here on this side, we went ahead and we're creating a tool body and cutting the tool body and then booleaning the tool body from the main piece there. And you'll see that we went ahead there and added the fillets around there and merged the top and bottom together. And you'll see here that we went ahead and filleted the transition between those. Now we're going to create a tool body on the back side. We're going to cut it with one of those planes. Looks like we're going to cut it again with another piece there. We're going to cut again, and then boolean that piece away. Again, just thinking of different ways of going about approaching projects. They all have pluses and minuses. So create another tool body, cut the tool body, boolean the tool body there away. And let's see what the next piece is here. Oh, so we created this little shimmy piece right here. So we extruded that, cut it with the plane, fit a plane, use that plane to cut it, use another surface to cut that, and then boolean it away. So you're just kind of separating this whole joint because the metal bends down and it's going to bend around that direction. So you see, then we're going to add the fillet there. You see that we're separating this from that. Now if we come down, we're going to work on this top. We're going to cut away that valley and fillet that. Then on the other side, do the positive and fillet that in. Now we're going to do some, Oh, before we do that, this is where the main piece comes in. So you see, so far what we've done is we've just modeled the entire top of the stamped out sheet metal part. Now we're going to say shell it. So we shelled it and got rid of all those back and side faces, and we now have a constant thickness part. Now from here, it's just dress up pieces. So add fillets, a bunch of these little dress up pieces there. Cutting our holes away from the side top there, and then adding this little piece there. So from here, you'll notice what we did is we took a slightly different approach. We modeled it as a solid body, concentrating on the top, then shelling the back away to make it a constant thickness part. The other things we learned from this is the fact that we went ahead and cut parts with reference planes. Instead of creating a lot of extra model geometry, we use reference planes to do a lot of our cutting and stuff, which is really neat. And then we use those reference planes to also trim tool bodies to then boolean away from the shape. So those are kind of three different skill sets that we see modeled within this.